Hi guys, tonight I'm going to take you through how to do this question on your trigonometry assignment. It's to analyse the functions y equal to sine x, y equal to cosine x, and determine the period and amplitude of the following graphs. So these trigonometry functions are called periodic functions, and the reason that they're called periodic functions is that they follow a pattern that repeats. And the length of time it takes for the pattern to repeat is called the period of the function. And that's the first thing that you have to calculate. The second thing is the range, which is that they always have a maximum and a minimum. So the difference between the maximum and the minimum is called the range of the graph, and that's the second thing you have to calculate. There's two ways of calculating them. You can calculate the period by reading it off the x-axis, and you can calculate the range by reading it off the y-axis and subtracting the difference between the top and the bottom to get the length of the maximum to minimum, which is the range of the graph. The other thing I'm going to explain to you is why these are pi's and not degrees on the x-axis when you're plotting the function. So angles can be measured either as degrees or radians. If you measure an angle on a unit circle, you always measure from 3 o'clock, and if you measure up, so there is 90 degrees up here. So the angles are measured in the square in the degrees. And what happens is if you go all the way around 360 degrees, that is the equivalent of 2 pi if it's measured in radians. So it's just a different measurement. So 360 degrees is 2 pi, 180 degrees is pi radians, and 90 degrees is pi over 2, and there is a full set of all of the major angles with their equivalent in radians. So to convert from degrees to radians and back, you use the calculation. 180 in degrees is pi in radians. So 1 degree is pi over 180, and then you just multiply it out. So 45 degrees is 45 multiplied by pi over 180. So that's how you convert from one to the other. So graphing the function of sine x, you have x here and y is equal to sine x, which you use your calculator to calculate, and then the y-axis here and the x-axis across for your degrees, and you plot it and you draw it and you get that lovely sine wave. The range is from the top to the bottom, so that's the length of that line from 1 to minus 1, which is 2, and the period is how long it takes to repeat. So the period of sine x is 360 degrees, or also we call it 2 pi if we measure it in radians. So the function cosine x follows exactly the same pattern. It's got the same range. It goes from 1 to minus 1. It's just shifted a little bit along, but it's got exactly the same period. So it takes the same amount of time for the pattern to repeat. So from 0 to 2 pi is its period. So the period of cosine x is 2 pi. The period of y is equal to sine x is 2 pi. So what would y is equal to sine 2x look like, and how does it compare to y is equal to sine x? So here we've plotted out x in the first column, 2x in the second column, and then the y value of sine of 2x. So the sine of, if x is 45, the sine of 2x is the sine of 90, so it's 1. So when we plot out these figures, the red is y is equal to the sine of 2x, and the blue is y is equal to the sine of x. You can see there are twice as many periods in the time that it takes one period for y is equal to sine x. So the wave goes through the cycle twice as fast. So we say the period of the sine of 2x is half of the length of the period of sine x. So what about sine 3x? So in this case, we've got red is y is equal to sine 3x, and we've got 1, 2, 3 periods in the length of time that y is equal to sine x has 1 period. So we go through 3 cycles, it goes through the cycle 3 times as fast. So the period of y is equal to sine 3x is 1/3 the length of the period of y is equal to sine x, We know the period of y is equal to sine x is equal to 2 pi in radians. So the period of y is equal